In this video we're going to anti-differentiate the product of the square root of 1 minus x squared and x cubed. And if you look at this, you know that you can't let u equal 1 minus x squared, because what would you substitute with dx? So the solution is that this is a trigonometric integral, because if I let x equal sine theta, then dx is cosine theta d theta. Okay. So now, when we substitute these two values in, we get a fun integral. So x is sine theta, so we'll have sine cubed theta times the square root of 1 minus sine squared theta, and dx is cosine theta d theta. Okay. So now, well, this gets a little more interesting, because this is 1 minus sine squared theta is cosine squared theta, and the square root of cosine squared theta is cosine squared theta. So I'm going to try to do what I'm going to do really slow here and not write everything down. This square root is all cosine theta, because 1 minus sine squared theta is cosine squared theta, and the square root of cosine squared theta is cosine squared theta, cosine theta. So this is cosine theta, and this is cosine theta. So when you multiply those two up, you're going to have sine cubed theta times cosine squared theta d theta. Okay. So now what? Well, we can split this into sine theta times sine squared theta times cosine squared theta d theta. Okay. And we are going to rewrite this as 1 minus cosine squared theta. So we'll have the integral of sine theta times 1 minus cosine squared theta times cosine squared theta d theta. Okay, now what? Well, now it's just a u substitution, because if I let u be cosine theta, we have another substitution. If u equals cosine theta, then du is sine theta d theta, but it's actually minus, but I'm going to put the minus over here, okay, because the derivative of cosine is minus sine, but because I'm trying to substitute sine theta d theta, so now in terms of u, we have the integral of 1 minus u squared times u squared times minus du. Okay. So let's continue. I'm going to move this up and start a new page here. Okay, so now we can multiply this out here, and when I do that I get u squared minus u to the fourth minus, I'm going to put this minus in front, du. Okay. Now we need to integrate. So when I integrate this, I get the opposite of u cubed over 3 minus u to the 5th over 5 plus a constant. Okay, now, so what's the problem here? Oh, let me move that over so we can see it. Alright, what's the problem here? Well, this is in x and this is in u, so we need to back substitute. Back substitute. So the first place to back substitute is to theta, and we said that u is cosine theta. U is cosine theta. So I'm going to rewrite this, I'm going to distribute this negative, so that's going to be cosine to the 5th over 5 theta. Okay. And then distributing, there will be minus cosine cubed theta over 3 plus a constant. Now yet we have another problem, and that problem is that the original integral was in x, not theta. So we said that, I want to put a little sidebar over here. We said that x is equal to sine theta. This means that sine theta is x over 1. So if I draw a right triangle, and this is 1, and okay, so here's our triangle. What we need is to know what cosine theta is. Okay. And using the Pythagorean theorem, we can conclude that this is the square root of 1 minus x squared. Okay. So cosine theta is the square root of 1 minus x squared. It's adjacent over hypotenuse. So substituting this back into this gives us 1 minus x squared to the 5 halves. Okay, because it's cosine to the 5th, but this is the square root. Okay, over 5 minus 1 minus x squared to the 3 halves over 3 plus a constant. So that is what the integral, so we can conclude that the integral of x cubed times the square root of 1 minus x squared is 1 minus x squared to the 5 halves over 5 minus 1 minus x squared to the 3 halves over 3 plus a constant.